Hey guys, we're going to learn our last unit of the year, sequences and series. This is going to be just adding and figuring out what our common ratio is in a pattern, okay? So I have this up here and I'm just going to write on this paper instead of the note packet so that it's bigger. But in your note packet, you have this paper like this. It says 7.1 sequences, and you've got this Pascal's triangle right here, and then some number series over here, okay? So the first thing it says is a sequence is just an arrangement of numbers, okay? So an arrangement of numbers means it's going to follow some sort of pattern, and we could figure out from one number to the next what the next number is going to be. And so we are we're going to look at what that would be on this one, okay? So with these numbers 2, 5, 8, 11, I look at those numbers and I could say, what is the pattern that's happening here, or how could I find the next number? And hopefully you notice that if I go from 2 to 5, I add 3. And from 5 to 8, I add 3. And from 8 to 11, I add 3. Okay? So because I'm adding the same number every time, if I add 3 to 11, I would get 14, and that would be my next number. Okay? This is a special kind of sequence called an arithmetic sequence. And we're going to talk about that in a minute, okay? The next one that we have is 3, 6, 12, 24. And I notice here that to get from 3 to 6, I multiply by 2. From 6 to 12, I multiply by 2. And we just continue multiplying by 2 to get to the next term and the next term and the next term. Okay? If we multiply by a number, that's called geometric. Okay? And then if we can just figure out a pattern in numbers, so like 8, 27, 64. So I'm not multiplying by the same number, and I'm not adding the same number. So I just have to figure out what each number is representing. So if I look at, if we start with n equals 2, and I did 2 to the third, I would get 8. And then if I increased 1, I would have n equals 3, and I'd have 3 to the third, and you'd get 27. And then this is n equals 4, and you get 4 to the third. Okay, and we can continue that same pattern. So my next term is going to be 5 to the third, which is 125. And I could find the next one, and the next one, and the next one, okay? So this is just a sequence because it's just a pattern that I've picked up on to find those terms. We're going to focus on arithmetic and geometric sequences today. And we're going to learn how to write a formula for how to find a term, or how to find any term, okay? So first of all, as we said up here, arithmetic means we're adding a common difference. So on your slide, you've got 9, 18, 27, and 36, okay? And it says determine if it's arithmetic. So to determine if it's arithmetic, I'm going to take this number, 18, and I'm going to subtract the 9. So 18 minus 9, and we get 9. Okay, then I'm going to do the same thing here. So 27 minus the 18, and we get 9 again. Okay, so I could continue figuring that out, and I'm going to get that 9 every single time. So it says determine if the sequence is arithmetic. Yes, it's arithmetic because I continue adding 9. I'm adding the same number. And what we call that is a common difference, because we're subtracting them to figure it out, right? So D equals 9. Yes, it's arithmetic, and D equals 9. Okay, Let's try the next one, negative 27, negative 32, negative 37, and negative 42. Okay, so we do the same thing to find that common difference. I take this term, negative 32, and we subtract the previous term. So negative 32 plus 27 gives us negative 5. And then if I do it again, negative 37 minus negative 32, we still get negative 5. So yes, it's arithmetic, and the common difference is negative 5. Okay, and then if you look at your next one, 7, 27, 127. So I'm not adding the same thing because this is 7 plus 20 is 27, and 27 plus 20 is not 127. So no, it's not arithmetic. Okay, so that's how you determine if something's arithmetic and how you figure out the common difference. You take the second term, subtract the first term, or the third term, subtract the second term. And the way that we identify these terms is I call this my a n minus 1 term, and this would be my a n term. Okay, so to figure out the next term, I add the 9 to the first one. Okay, and we're going to get into that in our next formulas that we talk about. All right, so our next slide gives us the formulas. So we've got the recursive formula, and it's going to give you some of this notation that we use for sequences and series with the AN. So sometimes it can look a little intimidating. Okay, AN equals AN minus 1 plus D. But if you remember, the AN minus 1, that just means the previous term. Okay, so this just means previous term. So we're going to do the previous term plus the common difference to get the next term. That's what that means. So the recursive formula, to be honest, isn't really that helpful because it will only tell us what the next term is if I have to know the term before it to figure it out. Okay, so for the recursive formula, so you have a problem here. It says 0.5, negative 1.1, negative 2.7, and negative 4.3. All right, so first of all, it says find the common difference. So I'm figuring out what am I adding to this in between to get to the next one. Okay, so negative 1.1 subtract 0.5. Put that in the calculator and you get negative 1.6. Okay, do it again. Negative 2.7 subtract negative 1.1. And we also get negative 1.6. And we could continue checking that, or you can just look and see, is it 1.6 away? Okay. And since it said to do it this way, then it's going to be. So our common difference is going to be negative 1.6. And then it says on the recursive formula. So this is the recursive formula. I don't know AN. I don't know AN minus 1. But I do know D. And that would be our recursive formula. So that would be, if I knew this term, I could subtract 1.6 to get to the next term. And that's the recursive formula. Okay, so the way this notation works, so I'm going to call this, this is going to be AN minus 1, and this will be AN, right? So to get AN, I'm going to subtract the 1.6 from the 0.5. So it would look like this. So AN is actually going to be our second term, right? Because this is the first one. So this is the second one. So I'm going to put a little 2 right here that stands for, the N just means what term I'm on. Okay, so if it says A2, this just means the second term. And then I'm going to do A, and then I have a 2 minus 1. Well, 2 minus 1 is just 1, okay? So A2 is equal to A1 minus 1.6. Well, A1 is negative 1.1, and if I subtract 1.6, I get negative 1.1, okay? Oh, I did that wrong. I'm sorry. A1 is 0.5. I put A2 in. So A1 is 0.5, and then we subtract 1.6, and that gives us the negative 1.1. That is the second term. So if I do it again, and I get the third term, okay, the third term is equal to the second term minus 1.6. And then the second term is equal to negative 1.1, and then we subtract the 1.6, and we get negative 2.7. And then if I wanted to get the fourth term, that would be A3 minus 1.6. And the third term is negative 2.7. And then I'm subtracting 1.6, and I get negative 4.3. And I could continue doing that for any term that I needed, right? The problem is that if I wanted the 100th term, I don't really want to go through this 100 times, okay? So let's see if there's another way we could think of to find the next term. And instead of using these decimal numbers to show you this, I'm going to put some numbers on here that are a little easier, okay? So let's say we've got 2, and then 5, and then 8, and then 11, okay? So I noticed that this is my first term, this is my second term, this is the third term, this is the fourth term, okay? And then how do I go from 2 to 5? So in between 2 and 5, I'm adding 3. And in between 5 and 8, I'm adding 3. And in between 8 and 11, I'm adding 3. So if I wanted 8/100, how many times would I add that 3 until I got to the 100th term? How many times do we add the 3 to get to the 100th term? So think about it like this. When I was looking at the third term, how many times did I add the difference, the 3, here and here? So that was 2 times 3. If I wanted the fourth term, I did 3 times 3. So if I wanted the 100th term, we would do 99 times 3. So it's always 1 less than the term, okay? So I would take this number, the 2, I would do 100 minus 1, and I would multiply that by 3. Because I would have these 3's that are up here, I would have 99 of those. So 99 times 3, and then I add it to my initial position. So 2 plus 99 times 3. You guys are going to have to do some math. So this would be 300 if it was 100, but it's not. So it's 97 plus 2. I'm getting 99. Okay, so that was a lot faster than going through and figuring out add 3 to this, 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 and keep doing that 99 times. No thanks. Okay, so this is another formula. It's called the explicit formula, because it will tell you how to find any term. Okay, so the explicit formula is a way to find any term. So I'm going to ask you these 3 things that you have to find or know for the explicit formula, okay? The first one is, what is the first term? You have to know A1. The second one is, what is the common difference? And then the third one, if it's asking for a specific term, you have to know what that N is. What is the term? Okay, so explicit formula is the formula for any term, and you need these 3 things. So let me write that on this page. And you have that formula on your page, okay? So AN equals A1 plus N minus 1 times D. Okay, so I need those 3 things, A1, common difference, and n to write the formula. So let's skip over to the next example. So we've got 17, 21, 25, 29, okay? So now I've got these 17, 21, 25, and 29. So first thing it wants is A1. So let's write our three things that we need. So A1 equals 17, common difference. So 21 minus 17, I get 4. 25 minus 21, I get 4. And 25 plus 4 is 29. Okay, so we can kind of look at it either way. And then n, on this example, it says find the 52nd term. So n would be 52. Okay, so the common difference is 4. That was the first thing it asked for. So let's put a little box around it that we found that. And then the 52nd term is going to be, so I'm going to have to write the formula. So let's just say an is equal to a1 plus n minus 1 times 4, right? Well, I probably should put a d there because we haven't filled anything in. So if we're filling this in, a1 is 17, and I'm going to leave it as a formula for a minute so that we can get the equation. So n is going to stay n, and it's n minus 1. So distribute the 4, so we get 17 plus 4n minus 4, 4n plus 13. So this would be our explicit formula, okay? So using that formula now, I could say what is the 100th term? And I could plug 100 in for n, and we'd get 400 plus 13 is 413. What's the 50th term? I can plug a 50 in here and get 213. Okay, so now it wants to know what is the 52nd term. So for the 52nd term, I do 17 plus 51 times 4. Or you could plug it into this formula. 4 times 50. This one would be 52 because it says actually n. Okay, so see, these are the two. This is before I simplified, and this is after I simplified. Okay, so we're going to get the same answer either way. Okay, so we're going to go 4 times the 52. I'll write it right here. You guys can't see my calculator. 208 plus 13. So the 52nd term is 221. Over here, if I did it this way, I would do 51 times 4 plus 17, and we get 221. So it doesn't matter which way you do it, you're going to get 221. Probably easier to go into the explicit formula that you found. So in that problem, it says find the common difference. I did. Find the explicit formula. I did. And find the 52nd term. I did. Okay. All right. Turn the page over in your notes. This one is a fraction one. Okay. So we've got -2, -2/3. So the three things I need is A1, I already know is -2. D, I need to figure that out. And 3n is 52. So we know 2 of the 3. Okay. So now I'm going to say, all right, what would D be? I'd go -2/3 and I would subtract -2, which actually means we're adding, right? So in my calculator, I'm going to go -2/3 plus 2, and we get 1.33333, and I don't want to use that. So let's put it in a fraction. So math, enter, that's 4/3. So D is 4/3, okay? All right, so then we have to write our equation. So AN equals A1, which is -2, plus n minus 1 times D. Okay. Now we distribute -2 plus 4/3 n minus 4/3. I'm going to put that in the calculator. So -2 minus 4/3. Fraction, -10/3. So AN equals -2 minus 10/3. 4/3 n, so that stays the same, and then minus 10/3. Just seeing if you guys are paying attention. Okay, so 4/3 n minus 10/3 is equal to our AN. So now if I want the 52nd term, that's pretty easy because I'm just going to go A52 equals 4/3 times 52 minus 10/3. And I'm going to put that in the calculator. Okay, so I'm going to go 4/3 times 52 and hit enter. I like to do them separate. You could do it together if you wanted. Minus 10/3. And we get 66. So our 52nd term is 66. Okay, so that's how you would do a fraction. You just need to use that math, enter to get a fraction instead of a long decimal. All right, so that is arithmetic sequences. Now we're going to go through those same processes for geometric sequence, okay? So move this down a little bit. So geometric sequence means you multiply by a common ratio, and we call that R. Okay, so geometric sequence, we multiply by a common ratio, R. All right, so what I want you to do is cross off on your packet right here, because this says geometric sequence, and then it says 2, 4, 6, 8, and that is not a geometric sequence. So cross that off, and we're just going to skip down to this where it says -4, 8, -16, and 32. Okay, so we've got -4, 8, -16, and 32. All right, so what do I multiply by? -4 to get 8. And let's actually write out so you know how to do it every time. Take this term, 8, divide it by that term, -4, and you get -2. Okay, do it again. -16 divided by 8, and we get -2. 32 divided by -16, and we get -2. So R is -2. Okay, we can do that on all of these. So the next one I've got 4, 18, 32, and 46. So 18 divided by 4, and put that in the calculator. Let's hold on to that for a minute, 4.5. Okay, and then 32 divided by 18. Math, enter, and I don't even need that as a fraction actually, because 4.5 and 1.78 are not the same, so it's not geometric. Okay, and then your last example is 2, -10, 50, and -250. So to get from here, I do -10 divided by 2 is -5. 50 divided by -10 is also -5. So I could keep checking, but I'm going to believe that it's going to be R equals -5. All right. So now we've got the two same type of formulas. Okay, so we've got recursive and explicit for geometric. So recursive is going to be AN equals AN minus 1 times R. That's all we're doing is we're multiplying that by R, okay? And then explicit, we're starting with A1 and we're multiplying by R, and we're doing that n minus 1 times, okay, to the power of n minus 1. All right, so that is going to be your main formulas, okay? So on the example, it says 3, 9, 27, 81. It says find the common ratio and the recursive formula. So common ratio 3 times 3, 9 times 3, 27 times 3. So R equals 3. Our recursive formula is the previous term times R. And that's all we can do, is just put that just like that, okay? Put that 3 there. And then your next one is negative 4, 12, negative 36, and 108. So this is multiplying by negative 3, multiplying by negative 3, multiplying by negative 3. So R equals negative 3. And my recursive formula is the previous term times negative 3. So there's not a lot to do besides plug in that common ratio right there. The one that you'll be doing more of is going to be finding the explicit formula, okay? So we've got 4, negative 20, 100, and negative 500. So first I need to find my 3 things. Do you remember what they were from the first one? What's the first thing we write down? Good, the first term. Then on this one, instead of D, it's R, and then we still need N. Okay, so A1, R, and then N. So A1 is 4, R, I could go negative 20 divided by 4 is negative 5. 100 divided by negative 20 is negative 5. So R is negative 5. Okay, and then N, if we read the question, it says, find the common ratio, the 10th term, and the explicit formula. So we already found the common ratio. R is negative 5. And then we're going to find the explicit formula. You don't have to write this every time, okay? When you write AN equals, that is what you mean, is the explicit formula. Just a reminder, the explicit formula is the previous term, or A1 times R to the N minus 1, okay? So A1, so if I'm writing my explicit formula here, A1 is 4, R is negative 5, and then that's to the N minus 1 power. I want you to be really careful that you do not combine this 4 and this negative 5. I cannot multiply these, no matter how bad you want to, because this negative 5 is stuck to a power, and this 4 doesn't have a power. So we can't just multiply that together and ignore the power. Okay, so we can't multiply that together until we plug something in for N, which we're about to do right here. So A52 is going to be 4 times negative 5 to the 52 minus 1 power. So 4, negative 5, oops, I put decimal 5, so no, I don't want that either. Negative 5. And I'm going to do the 52 minus 1 is 51 power. And we get this really big number. Oh, 52. You guys, come on. Come on, Miss Runkles. You can read. We're actually doing 10. So instead of 52, let's do 10. Otherwise, we're going to have an outrageous number. And this will be to the 9th power because 10 minus 1 is 9. All right. So we get negative 7812500. If you want to try and say that, you can. Okay, so this would be our 10th term. So notice how it asked for 3 things. I spelled out those 3 things. This is R, this is the explicit formula, this is the 10th term. Okay, it asked you for it again right here. So 3, 15, 75, and 375. So I need my 3 things. Okay, so the 3 things is kind of a trigger word for you to remind you what it is that you're looking for. So if I say, what are the 3 things you need to know the first term, the common ratio. So 3 times 5 is 15. 15 times 5 is 75. So we're looking at times 5. And then n is 10. Believe it or not, we're going to plug a 10 in. Okay, so the ratio is 5. The explicit formula is a1 times 5 to the n minus 1. That's all I can do. I'm not going to multiply the 3 times the 5. Okay, and now we're doing the 10th terms. We have 3 times 5, and then 10 minus 1. 3 times 5 to the 9th. And then I put that in the calculator. 3 times 5 to the 9th. And we get another really big number, 5859375. Okay, so that is all we're doing for arithmetic and geometric sequences. It's just the introduction for it. And then in the next couple of days, we're going to start adding them together, adding the terms together, finding the sum, and then making it an infinite series. Okay, we'll see you later.